This is the Unit 5 progress check part A. So number one is a calculator question. Let f be the function given by that right there. The derivative of f is given right there. What value of c satisfies the conclusion of the mean value theorem applied to f on the interval 1 to 4? So we want to apply the mean value theorem. The mean value theorem, you have to have a continuous and differential function, which f of x is. In fact, we know it's differential because it gives us the derivative there. And the mean value theorem says that if we connect the endpoints of the interval 1 to 4, then some, and this is not the actual drawing of it, so from 1 to 4, if we connect those endpoints and find that slope, there will be at least one point between 1 and 4 where the graph will have a tangent line with the same slope. So what we want here is we want the derivative of some value between 1 and 4 to be equal to the slope of that line. So as we look at our choices here, we need a derivative to be equal to a slope. Well, in part A, this says a function is equal to a slope. We don't want a function equal to a slope, f of x, so it's not that. B, 2.749, because the derivative of 2.749 equals, so is this a slope, f of 4 minus f of 1 over 3? Well, remember we have y2 minus y1 over x sub 2 minus x sub 1, and so that's what we have there. And 3 comes from 4 minus 1, so it could be B. C, it could be C because it has a derivative and the derivative is equal to something. So if the slope is 0, then C could be one of the answers, or it could be an answer. And part D says the derivative is equal to this fraction here. This is not the slope. This is actually the average. So you're taking like y sub 2 plus y sub 1 over 2. So it's definitely not D. And so really, as long as we could find the slope and see if it equals 0. If it does, it's this one. If it doesn't equal 0, it's that one. So so what we can do here is we can do f of 4 minus f of 1 over 3. So we can bring out our calculator here. In y sub 1, I have our function. So let's go ahead and graph this. And this is different than probably your graphing calculator. So you do have to know your own. So here I have the graph. I want f of 4 minus f of 1 over 3. So what I can do here is I can go to calculate. I just want to find the value when x is 1. So I'm going to type in 1. It tells me that value is 1.54. So I kind of did that backwards. So here I'm doing this. F of 1 is 1.543. F of 4 is 0.52. 0.525, sorry, negative 0.525 over 3. And so we can find that. So we'll get out of here for right now. We'll go back to the original screen. We have negative 0.525 minus 1.543. And the fact that that is not equal to 0 tells me it's not C. And so the answer has to be B. We didn't actually find everything, but the answer does have to be B. What we could do is we could now go, we don't have to do anything else, but if it's a different question with different choices, we know that's the slope. So we would go to our slope, the derivative, and we would want to find, when the derivative equals 2.749. So 2.749. All right, so number 2, the derivative of a function f is given by that function right there, on which of the following intervals is it decreasing. So we know f is decreasing if the derivative is negative. So if f prime is negative, then f is decreasing. So all we need to do, this is a calculator question, so all we need to do is we need to graph the derivative, which I have in here on this one, x squared minus 2 minus 3 cosine of x, and we want to find when f prime is negative, which means below the x-axis. So let's graph this. We want to find when it's below the x-axis between -4 and 3. So can zoom in a little bit. So it looks like -3 point something to -1 point something. And we could find those values. This one, it's really easy. I can just come down here from -3.44. It's negative all the way to -1.8. So really the only one that has that in there is this one. Continuing, it's negative from -0.66 all the way to 1.509. So the answer is C. So that was nice and simple. Number 3, the temperature inside a vehicle is modeled by the function f, where f of t is measured in degrees Fahrenheit and t is measured in minutes. The first derivative is f of t is t squared minus 3t plus cosine t. At what times t between 0 and 4 does the temperature attain a local minimum? So a local minimum. Again, we can use our graphing calculator. So we want to know when f has a local minimum. So that will be when the derivative is 0 or undefined. And so on a graph, that's when it hits the x-axis. So let's come back to our graph. Let's graph this function, which I already have typed in there, x squared minus 3x plus cosine x. And those are in t, but we have x in there, and that's fine. So we'll go ahead and graph that. We want to know when it hits 0. Well, it hits 0. Again, you can use your calculator's functions at 0.354 and at 3.299. Well, we want to find a local minimum. A local minimum, so we know there's zeros at those two spots. However, what we want to do is we want to look at the derivative to the left of that spot and to the right of that spot. So I'm just doing this because I can't draw my graphing calculator. At this first value, it goes from positive to negative. Well, when a slope goes from positive to 0 to negative, that's a maximum. So it went from positive to 0 to negative. That is a maximum. Well, when it goes from negative, so it's under the x-axis, so that's a negative slope, to 0 to positive, this is positive, then that's a minimum. So there's a local minimum at that second value, which is 3 point something. So it looks like it's 3.299. All right, we don't need our calculators anymore. Number 4, let f be a function given by that rational function there on the closed interval -7 to 7 of the following intervals, on which can the mean value theorem be applied. So the mean value theorem, a function has to be continuous and differentiable. So our function here has two vertical asymptotes, make the denominator 0. So we know that it's not defined at -2, and it's not defined at 4. Maybe I can just get rid of this. We can just use a number line here. And so everywhere else it is continuous and differentiable, so we just have to find an interval or intervals that won't cross over that -2 or 4. So from -1 to 3, from -1 to 3 is from about here to here. That's okay, so that one's fine. That's a check. From 5 to 7, because it's continuous and differentiable on 5 to 7, is that okay? Yep. So from 5 to 7 is from here to here. Let's say this is 7. That's okay. And that's a check. And then from 1 to 5, 1 to 5 crosses over that 4, so not this one. So 1 and 2 only, so our answer is C.